principle that we have learned now. We are saying a set can be written in exponential form. So if we do 2.2.2, we'll say, okay, we have 2.2.2. Now this thing here, it means this whole thing here, we have an n here. Can you see that? Okay? So it means that we can write this everything to the power of 1 all over m. Then we can come and work with this thing and say, okay, but now inside here we have a 6. We're going to change 6 as a prime product. So if we write 6 as a prime product, we can say this is going to be written as 2 multiplied by 3 to the power of what? Of m. Plus 5 multiplied by 3 to the power of m, close bracket. And then 10, if we write 10 as a prime factor, so we're going to change 10. 10 is going to be written as 2 multiplied by 5, all to the power of what? Of m. Plus, we can split this because of this plus. So we can write it as 5 to the power of m multiplied by 5 to the power of 1. Okay, now guys, from here, we shouldn't forget that this thing here we still have outside, it's not clear. So we still have 1 all over m. Now, the tempting thing that learners usually make is that they will say this one multiplied by this one multiplied by this one. Now, it's worth reminding a learner that when we had something like this, a plus b all squared, because of this plus, we couldn't raise the power to the first power. So how did we do this one? We expanded again. We said this means we should repeat this bracket 2 times, a plus b, a plus b. So Elena is not allowed to do that. As much as it's tempting, I know it is tempting for you to say we're going to raise the power to the first power. So what we'll then do first is like, let's go and factorize. We want to remove the plus and the minus again. Now, the best way you can remove the plus and the minus is to simplify. So you can come and say, okay, we have here this one multiplied by this one multiplied by this one. Let's remove this. This doesn't work. We don't have this. And then here we're going to have 2 to the power of m multiplied by 3 to the power of m plus 5 multiplied by 3 to the power of m, close bracket. All over, we repeat the same process then. This one multiplied by this, 2 to the power of m. So this is going to be multiplied by 5 to the power of m plus 5 to the power of m multiplied by 5 to the power of 1. Now this is still inside the bigger bracket, which is going to be what to be 1 all over m. Don't forget that, guys, it's still there. So it means with this thing is still under the root, yes. What? How did I get what? 1 all over m. We are saying again, we can write this thing here. It's in a set form. Can you see that again? Since it's in a set form, it means like I can change this set and then write it as an exponent. Did you see this part when we're speaking about if I have root a, this is going to be written as a to the power of 1 all over 2. So this is going to be written as a to the power 1 all over 2. You were here when I was explaining this part. You didn't understand it. Okay, let's do it again. So what are we saying here? We are saying we have an exponent and then we have a set. So something in an exponential form and something in a set form. So these are the inverse of each other. I can write something as an exponent, I can write something as a set. Yeah? So if I give you something like this, let's say I give you a cube root of x, for example, to the power of 1. Yeah? Let's make, if they didn't write anything, means this to the power of 1. Yeah? So let's write this in a set form. So if this is in a set form, I want to write it in an exponential form. Yeah? So if I were to write it in an exponential form, I'm going to open a bracket and write my x with its exponent. So it's going to be x to the power of 1. Now, this here, a root, it's a fraction. So it's going to be 1/3. It's 1/3. And then, no, it's not always 1 all over 2. It's 1 all over whatever is written here. And then you should differentiate between 3 root x and then cube root. It's smaller, and then this one is 3 root x. So those are two different things. As we move on here, we are saying this, as we remind each other, this is going to be written as this one multiplied by this one is going to be x to the power 1 all over 3. Same principle here. The same principle that we've used there, we're going to use it here. We say to you, okay, how did we get this to be like this? So we are saying we have m here again. So it's going to be 1 all over m. So this thing is going to be written as 1 all over m. And then we work out whatever is inside the bracket. Okay, we move on. Now from here, guys, you can see something which is very important. There are start with our numerator. On our numerator, we have term number 1, we have term number 2 again. Now, between term number 1 and term number 2, is there anything that appears this side and that side? Okay, what is that thing? So we take 3 to the power of m. If we take 3 to the power of m, we are left with 2 to the power of m plus 5. Okay, that's the first thing that I'm left with. Okay, let's go to the denominator. On my denominator, this is term number 1, this is term number 2. Is there anything that is common between term number 1 and term number 2? Okay, what seems to be common? It's 5 to the power of m. So if I take 5 to the power of m here, what am I left with? 2 to the power of m plus 5 to the power of 1, close bracket. But this is still inside the bigger bracket, which is 1 all over m. Okay? Now from here, you can clearly see that we have something that appears on the denominator and then it also appears on the numerator. So they can divide each other out. So I'm going to be left with 3m all over 5m to the power of 1 all over m. Now then from here, you can raise a power to the furthest power. You can say, because again, like we no longer have plus and a minus. We have a multiplication and a division. So we have a division here. I would say this one multiplied by this one. It says I'm going to be left with 3. How did I get 3? Again, it's m multiplied by 1, which is going to give me m all over n. Okay, here I'm going to do exactly the same thing. This one to the furthest power, it says this is going to be actually 5. And then if we were to mark such a question, we'll give you 1 mark. For factorizing, you'll get 1 mark. Factorizing the denominator, 1 mark. Answer, 1 mark. And then writing this as 1 all over m will also give you a 1 mark. Changing this thing here from a surd into a rational exponent.